Hey guys, what's up? We're back with day 33 here. We're going to look at some more PVA. Um, Today we're going to look at some interesting problems that I want you to pay attention to, um, and also some calculator problems. So let's take a look at this problem. It says a cat's velocity is modeled by v of t equals t minus 2 times 2t minus 8 times t minus 6 squared times t minus 8 for t greater than or equal to 0. I want you to find the time or times when the cat changes direction. Okay? So again, we need to know, anytime they're asking you about something changing direction, we got to know it's when velocity changes signs. The nice thing is we already have the velocity equation here, right? And the other nice thing is it's already factored for us. So to find the times when the cat changes direction, we need to find all the zeros of our velocity, and then we need to do a test, right? Just because there's 0 doesn't mean necessarily that the cat changed directions there. So we have to test to make sure that those points actually work. So the first thing I want you to do is think about setting v of t equal to 0 here. What are we going to get for our candidates? So what are we going to get for our candidates? Well, when I look at this equation, it's already factored, right? So you can set each factor equal to 0 to solve, right? So I'm going to set t minus 2 equal to 0. Again, we're setting this whole equation here. We're setting this whole thing equal to 0. So we can set each part equal to 0. If, excuse me, t minus 2 equals 0, then we get t equals 2. That's a candidate. 2t minus 8 equals 0. And that gives us t equals 4 as a candidate. T minus 6 squared. Right, we can do the square root of both sides, the plus or minus square root, but it's 0, so it doesn't really matter. So we get t minus 6 equals 0, and we get t equals 6 as an answer. And we get t equals 8. Right? So those are our candidates, 2, 4, 6, 8. So what we want to do is, those are our candidates, those are not necessarily our answers. We want to make a v of t number line here. And on this v of t number line, we want to place our zeros. So we're going to place 2, 4, 6, and 8. What I want to do now is just test numbers around to make sure I actually switch signs. So, and we have to have t greater than or equal to 0. So since t must be greater than or equal to 0, that includes 0. When I do my tests, I like to mark up my equation here. And I just have to be very careful when I do this. So when I plug in 0, right, I'm going to use my test point as 0. If you want to use 1, that's fine. When I plug 0 into this one, I get 0 minus 2. 0 minus 2 is a negative number. Remember, I'm not concerned about the number here. I'm concerned about the sign. So I'm going to get a negative for the first one. 2 times 0 minus 8 is a negative for the second one. 0 minus 6 is negative, but notice it's being squared. So negative 6 squared makes a positive number. And in fact, for any number I plug into that t minus 6, I'm always going to get a positive number. And then 0 minus 8, I'm going to get a negative. Now I'm going to go through and see what's going to happen when I do negative times positive times negative. Well, a negative times a negative is a positive. A positive times a positive is a positive. A positive times a negative is a negative. And I get overall a negative velocity there. The other way you can do this is just count the number of negative signs. If the number of negative signs are an even number, it's going to be positive. If it's odd, it's going to be negative. If there are no negative signs, if they're all positive, obviously it's positive. So we had 3 negative signs there, which meant it would be negative. Now I need to choose a number between 2 and 4. So I'm going to choose 3, right? And I'm going to go up and I'm just going to adjust my signs. 3 minus 2 now, right here, 3 minus 2 now is a positive number. So I have plus, 2 times 3 is 6, 6 minus 8 stays negative. 3 minus 6 is a negative, but it's squared. It's going to become a positive. This one is, again, always going to be positive. And then 3 minus 8 is negative. So now I count the number of negative signs. I have 2 of them, 1 here, 1 here. 2 negatives means it's going to be positive. Or you can go through and say, okay, positive times a negative is a negative. Negative times a positive is a negative. Negative times a negative is a positive. Now I need to check numbers between 4 and 6. I'll use 5. 5 minus 2 is positive. 2 times 5 is 10 minus 8. And this is now a positive. 5 minus 6 squared is still always positive. 5 minus 8 is negative. I only have 1 negative sign. That's an odd number, so I know it's going to be negative between 4 and 6. Next, I'm going to check a number between 6 and 8. I'll use 7. 7 minus 2 is positive. 2 times 7 is 14 minus 8 is positive. 7 minus 6 is 1. 1 squared is positive. 7 minus 8 is negative. So I have the exact same setup, so I get a negative again. And when I use a number bigger than 8, let's use 9. 9 minus 2 is positive. 2 times 9 minus 8 is positive. 9 minus 6 squared is positive. This one now, t minus 8, 9 minus 8 is now positive. And I get all positives, so it's positive. Taking a look at my v of t number line now, I want to know, where did this cat change directions? Well, any number, any t value where my velocity sign switched. So I'm going to say t equals 2, because velocity went from negative to positive. T equals 4, velocity switched from positive to negative. But take a look. T equals 6 is not a place where the cat changed direction. It went left, stopped, and then kept going left. So t equals 6 is not an answer, but t equals 8 is. So t equals 2, 4, and 8 are times when the cat switched directions. And if we had to justify it, we'd say because v of t switched signs at those times. So that's a type of problem we can see from time to time. One thing I want you to get used to seeing is if you see like a t minus 6 squared, that was kind of the giveaway that that was not going to be one of our answers, because we're not actually going to be switching signs at 6 there, because whatever t minus 6 squared is, it's always going to be a positive number. Okay, I want to look at a real AP problem from 2016. So take a look at this prompt. What's different about this one is this one we can use our calculator on. So this one is calculator okay. So reading the prompt here, it says for t greater than or equal to 0, a particle moves along the x-axis. The velocity of the particle is given by this equation. So we have v of t equals 1 plus 2 sine of t squared over 2. That is our velocity equation. It says the particle has a position at x equals 2 at time t equals 4. That is going to be a really important piece of information for us later. It is not a very important piece of information for parts A and B, which we're looking at right now. Okay, so let's take a look at this and see how our calculator can help us get this. Part A says at t equals 4, is the particle speeding up or slowing down? Okay, we talked about this in class. What do we need to do? Right? Pause the video and think, what do I need to do to answer this question? The answer? I need to find the velocity at 4 and the acceleration at 4 and compare those signs. If v of 4 and a of 4 are the same sign, the particle is speeding up. If v of 4 and a of 4 are opposite signs, we know it's slowing down. So let's talk about how we can use our calculator to our advantage here to solve this thing. The first thing I want to do is I want to go to my graph, right? And I want to graph my velocity equation. So go ahead and take your graphing calculators out. The more you practice doing this on the calculator, the easier it'll become and the faster you'll be at it. So first off, I need to make sure my calculator is in radians, which it is. Now I'm going to go to y equals, and I'm just going to type in that function and clear all the other stuff that's in there. So my function is 1 plus 2 sine, and I can't quite remember what it was, 2 sine of t squared over 2. I'm going to put my fraction bar in there, alpha y, enter. And I'm not going to use t, I'm going to use x. It's the same thing. Now, the key here is whenever you enter something like this, do so very accurately, the best you can. Okay? The other thing I like to do, sometimes these weird functions take a while for your calculator to graph, so I like to set a good window to start. Now I know for my window, it says that t, or in this case x, must be greater than or equal to 0. So I'm going to set my x min at 0. I'll let my x max be 10. I just need to make sure that an x value of 4 is in there because that's what we care about. So let's take a look at what this graph looks like. We can see it's kind of a funky looking graph here. But again, it's useful and it's gonna help us solve the problem. So again, my mission here is I need to find v of 4 and I need to find a of 4. Now again, remember, what graph did we just put in? Well, we just put in a graph of velocity. If I want to find the velocity of 4, all I have to do here is trace 4. So I'm just going to hit the trace button and then touch the number 4. And I'm going to write my answer down out to 3 decimal places. So v of 4 is 2.979. So I know v of 4 is equal to 2.979. I don't care so much about that number. I care whether or not this is positive or negative. This number is greater than 0. So I know that v of 4 is positive. That is not enough to answer this question, but it is important. The next thing I need to figure out is I need to find a of 4. Now, some people will sit there and say, okay, let's go ahead and do the derivative of v of t and graph it. Right? That would be one strategy. But we'd have to do a chain rule there to do that, and we might make a mistake doing it. There's a really, really easy way to find a of 4 quickly, right? We know it's the derivative of v at the point 4. Well, our calculators are really good at calculating numerical derivatives. So check this out. Here's what I'm going to do. I'm going to go to second calculate, so hit the second key and then the trace button. Look at number 6, right? If I scroll down here to number 6, I can do the derivative, and it wants to know at what x value. I'm going to type in the number 4. And it tells me dy dx. Look at that. It says dy dx equals negative 1.164. So I'm going to go back to my paper. And I'm going to say A of 4 equals negative 1.164. I didn't even have to do a derivative. I didn't have to do the chain rule. It was way easier than that. That means that A of 4 now is less than 0. So V of 4 is positive, A of 4 is negative. What does that mean? That means the particle is slowing down. At t equals 4. Because V of 4 and A of 4 are different signs. This would be a little bit harder of a problem without a calculator. It's one that we could do, but it would be a huge pain in the butt to figure out without a calculator, right? So oftentimes when we see these kind of crazy, weird functions, don't worry, we have a calculator and it can crank that out. But again, the key concept here is to figure out if the particle is speeding up or slowing down. I need to check the sign of V of 4 and check the sign of A of 4. Since they were different, I know the particle is slowing down at t equals 4 because V of 4 and A of 4 are different signs. Take a look at part B. Part B says, find all the times t in the interval 0 to 3. Notice that does not include 0, does not include 3, when the particle changes directions. It also wants us here to justify our answer. So what I'm going to do is I'm going to go back to my graph, and now I'm going to restrict my window to just look between 0 and 3. So bear with me while I go back here. Let me go back to my window, and I'm going to restrict my t, or in this case x, between 0 and 3. All right, so there's what we see. That's the window we're looking at. And again, the question is, when does this particle change directions? Well, again, that's a huge keyword in our PVA problems. An object changes directions when velocity changes sign. Now again, what are we looking at? What is this graph the graph of? Well, this is the graph of velocity. Does anybody see where our velocity is going to be changing signs? Our velocity is going to be changing signs right here. Velocity is positive to the left of this number, or sorry, yeah, positive to the left of the number and negative to the right of that number. Okay? All in here, this whole stretch here, velocity is positive the whole time. On this stretch here, velocity is negative the whole time. The question is, how can I figure out that number accurately to 3 decimal places? Well, our calculator, right, obviously that's a 0. So I'm going to have my calculator calculate that 0 by going second trace. And option 2 here helps us find the 0. We just want to click on a point left of that 0, and then we'll just arrow over until we're right of that 0. This kind of takes a little while. Just going to arrow until I make sure I'm to the right side of the 0. Okay, and I'll hit enter, and then I have to enter one more time. And I can see that that t value, now your calculator reports it as an x value, but that is a t value of 2.707. So let's go back to our dealio here. There was only one answer to that problem, and I would say the particle changes direction at, don't say x, at t equals 2.707 because I need to justify. My justification is because I don't say it changes signs there. I say because v of t changes signs. At that time. Okay. So it ends up being a pretty simple problem. Parts A and B here were pretty easy points to earn. Right? Parts C and D were a little bit more tricky, and we can't do them yet, so I cut them off. That's it for today. I'll try and hit you with another video tomorrow with some more practice problems. Talk to you guys later. Bye. Two train.